Today, we're diving into a world that's completely invisible to the naked eye. We're going on a high-stakes quest for a single microscopic treasure. We're talking about TESE, or Testicular Sperm Extraction. But this isn't just a story about some medical procedure. This is a story told from the perspective of the embryologist right there on the front lines, the incredibly skilled artists who do this delicate work day in and day out.
And this quote, this is the key to the whole thing. To them, this isn't just science, it's a mining operation. They're literally heading deep into the source, the testis itself, on a mission to find something unbelievably precious and rare. This metaphor just perfectly captures the patience, the skill, and let's be honest, the immense pressure involved. So, go ahead and grab your hard hats, we're heading into the mine.
So why is this whole microscopic mining mission even necessary? Well, it all kicks off with a very specific diagnosis, what we can call the zero sperm problem. It's a situation where all the standard methods just aren't going to cut it, which forces this journey directly to the factory floor.
Okay, so the official medical term for this is azoospermia. And all it means is that, for whatever reason, there is literally zero sperm found in a man's ejaculate. That diagnosis is the starting point. It's the reason this whole TESE expedition gets launched in the first place. But as you're about to see, not all of these mines are created equal.
Before any digging can begin, the embryology team needs a map. They have to understand the kind of terrain they're dealing with. You see, Azoospermia actually comes in two very different forms, and figuring out which one you're up against, well, that changes everything. The strategy, the tools, and yeah, the chances of striking gold.
The embryologists have this brilliant analogy for this that just makes it all make sense. So on one hand, you have obstructive azoospermia. Think of it this way, the factory is working perfectly. It's turning out plenty of sperm, but all the roads leading out are blocked. This is the embryologist's favorite case, because success is pretty much a sure thing. But on the other hand, you've got non-obstructive azoospermia. And here, the problem is the factory itself. Production is either stopped completely, or it's only happening in these tiny, isolated little pockets. This is the true needle in a haystack mission.
And that right there is exactly why TPSC is so critical. When the main roads are blocked, or when the factory itself seems to be shut down, you've got to go off-road. You have to bypass the whole distribution network and go straight to the source, tunneling right into the tissue where production is supposed to be happening.
So, the mission is set. The urologist retrieves a tiny piece of tissue, and it arrives in the lab. This is the moment our skilled miner, the embryologist, takes over. The excavation is about to begin. And believe me, it's a process that demands unbelievable focus and a super steady hand.
The first phase is all mechanical, a real work of microscopic precision. The tissue sample, which has countless little sperm-producing tubules inside, is placed in a petri dish. Then, using two sterile needles, the embryologist just meticulously, carefully minces the tissue. The goal here isn't just to chop it up. It's a strategic move designed to gently break open those tubules and hopefully release any sperm that might be trapped inside.
But what happens if that first mechanical search turns up empty? Well, the embryologist has a chemical ace up their sleeve. They'll bring in an enzymatic solution that basically acts like a biological solvent. It carefully dissolves the tissue, holding everything together to release every single last potential sperm. It's like the final all-out search to make sure no treasure gets left behind.
Okay, so finding the sperm is only half the battle. Now you have to secure the treasure. And this material you just can't imagine how precious it is. Every single piece of tissue, every drop of fluid could be the key to a future family. Absolutely nothing can be wasted.
I mean, this quote from an embryologist says it all. This isn't just some biological sample, it's gold. It represents hope, time, so much effort. And because of that, every last bit is carefully preserved like a treasure locked away in a high-tech vault of liquid nitrogen.
So how do they preserve it? Well, it happens in two main ways. The team can freeze pieces of the tissue itself, basically preserving entire sections of the mine for a future expedition, or they can freeze the liquid suspension that already has the sperm they've found. And for these incredibly precious samples, they even use these special high-security straws just to make sure not a single potential life gets lost.
We now come to what one embryologist called the hardest part. The long search is over, sperm had been found. But the mission is not complete, not even close. Now, out of maybe just a handful of candidates, they have to pick the single best one to inject into an egg.
And this is the ultimate challenge. See, unlike sperm from an ejaculate, TESE sperm are almost always immotile. They don't swim. They just lie there. So if you're looking through the microscope, how on earth can you tell the difference between a sperm that's alive but just not moving
and one that's dead. Because injecting a dead sperm means it's all over. I mean, the stakes just don't get any higher.
This is where science really becomes an art form. To figure out if a motionless sperm is alive, embryologists have these incredibly delicate tests. They might use a microscopic glass needle for a mechanical touch, just gently poking the sperm's tail. A living sperm's tail is flexible and will spring back. A dead one is rigid. Or they can try a chemical kickstart with a special solution that can jolt a living but sleeping sperm into giving a subtle twitch. And that twitch? That is the definitive sign of life they've been so desperately searching for.
Once a living sperm is identified, the final selection is made based on its morphology. The embryologist is looking for the best possible shape, a smooth head and a strong, straight tail. This single champion, the best of the best, is then carefully isolated, ready for its one ultimate purpose, fertilization.
So, after all the hours of searching, the delicate dissection, the nerve-wracking tests, and the intense concentration, this entire monumental effort, it all boils down to one single, powerful idea.
It all comes down to this number, 1. Just one viable sperm. The success of this entire massive microscopic mining operation, it all hangs on finding just one. A single cell holding all the genetic data needed to create a brand new life.
And that's really the crucial point here. A piece of advice straight from the embryologists on the front lines. They might spend half their day hunched over a microscope, just searching for that one little flicker of life. They do it because they know that one sperm isn't just a cell. It's a couple's last chance. It is the ultimate treasure from the microscopic mine. And finding it, well, it's just this profound testament to patience, to skill, and to the simple, powerful act of never, ever giving up hope.